Friendly Telugu greeting. Hey everyone, welcome to our guide on Java string handling. Now, if you're getting ready for your Java exams, you already know that strings are a huge deal. I mean, they're literally everywhere. So getting a really solid handle on how they work, that's your ticket to boosting those scores. Let's dive in and master this thing together.
Okay, so let's kick things off with the big question, right? Why in the world does Java give us 3 different classes just for handling text? I know, it sounds kind of complicated at first, but trust me, there's a really smart reason for it. It all boils down to performance and memory, and we're going to get to the bottom of it right here.
All right, first things first, the absolute basics. You know, in some programming languages, a string is just, well, a list of characters. But in Java? Oh, it's so much more than that. A string is an object. Think of it this way. The word hello isn't just a word. It's this smart little container that holds the letters and comes with a bunch of built-in tools, we call them methods, that you can use. Grasping this one idea is super important.
So, here's a quick look at our game plan. We'll start with those 3 main string classes. Then, we're going to do a deep dive into the string class itself. After that, we'll see how it stacks up against its 2 cousins, StringBuffer and StringBuilder. We'll also check out some super useful methods, and then we'll wrap it all up with a simple guide to help you totally ace those exam questions.
All right, let's get right to the heart of it. Anytime you're working with text in Java, you've got this choice you have to make between 3 different classes. And yeah, you guessed it. Knowing which one to use and when is a classic exam question. And here they are, our 3 main players: string, StringBuffer, and StringBuilder. And what's really cool is that they're all part of the standard java.lang package, which means you can use them right out of the box. No special imports needed.
Okay, now listen up, because this is the single most important thing that separates these classes. It's the idea of being immutable versus mutable. The good old string class is immutable. That means once you create it, it's set in stone. You cannot change it. But StringBuffer and StringBuilder, they're mutable, which means you can tweak and change them all you want. If you remember just one thing today, make it this.
So, let's zoom in and put the string class under the microscope. This is the one you're probably going to use most of the time, so it's absolutely crucial to understand this whole immutability thing and how it handles memory, especially for your exams.
So what does immutable really mean when you're coding? Well, here's a great way to think about it. A string object is like a printed photograph. If you want to say, give someone in the photo a different hat, you can't just draw on the original print, right? You have to take a whole new picture. It's the exact same with string. When you think you're changing it, what's really happening behind the scenes is that Java is creating a brand new string object in memory.
And that leads us to a classic exam question that trips a lot of people up. Where are these string objects actually stored? Well, the answer isn't so simple. It actually depends on how you create them. Let's check it out. You've got 2 ways to make a string, and each one sends it to a different place in memory. If you use the simple double quotes, like in that first example, the string goes into this special, super efficient area called the string constant pool. But if you use the new keyword, it gets created in the main heap memory, just like all the other regular objects. And this is where Java gets really clever. The whole point of the string constant pool is to save memory. So if you create a string with the value Java, and then later on you try to create another one with the exact same value, Java is smart about it. It doesn't waste space creating a new object. Instead, it just points your new variable to the Java that's already sitting in the pool. Pretty slick, right?
Okay, brace yourself for this one. This is probably the most common exam question about strings, period. Because of those 2 different memory spots we just talked about, comparing strings isn't as straightforward as you think. You've got 2 ways to do it, and they do not do the same thing.
Let's break this down. The double equals operator, double equals, is basically asking, are these 2 variables pointing to the exact same object in memory? It's comparing the memory address. The dot equals method, on the other hand, couldn't care less about memory addresses. It actually looks inside the objects and compares the letters one by one. It's asking the question, do these 2 strings have the same value?
So what's the golden rule here? It's simple, and you have to remember this. Whenever you want to check if 2 strings have the same value, you always use the dot equals method. Seriously, using the double equals operator by mistake is one of the most common bugs you'll find in Java code, so be really careful with that one. Okay, so we got a pretty good grip on the immutable string class. But what if you actually need to change a string over and over again? Like maybe you're building a long piece of text by adding bits and pieces to it. Well, that's where our mutable friends come into play. Just think back to our photograph analogy for a second. Creating a brand new photo every single time you want to make a tiny little change would be a huge waste of time in film, wouldn't it? Well, it's the same thing with string. Creating new objects again and again is slow and it creates a ton of garbage that the system has to clean up. StringBuffer and StringBuilder are the answer. They let you modify the original object directly. No waste.
So, if they're both mutable, how do you choose? Well, it all comes down to something called thread safety. Imagine you've got a Google Doc, and two people are trying to edit it at the exact same time. You need some rules in place so they don't mess up each other's work, right? That's kind of what StringBuffer does. It's thread safe, which makes it safe to use when multiple processes might be changing it at once. But that extra safety makes it a little bit slower. StringBuilder, on the other hand, doesn't have those safety rules, so it's faster. For most of your day-to-day coding, StringBuilder is going to be your best bet.
Now, all three of these classes come packed with a whole bunch of methods to help you work with text. So let's just do a quick flyby of some of the most common ones you'll absolutely see on your exams and use in your projects.
Here are a few of the big ones you'll use constantly. .length is simple. It just tells you how long the string is. .char_at lets you grab a single character from a specific spot. .replace is awesome for swapping out parts of a string. And pay close attention to .append and .reverse. These are your go-to tools for actually changing strings when you're using StringBuffer and StringBuilder.
Phew, we have covered a lot of ground. So now let's pull it all together into a simple, crystal clear guide. This is the part you want to take a screenshot of or write down to memorize for your exam. When do you use each class? And here it is, your ultimate exam cheat sheet. Let's walk through it real quick. For mutability, you see string is immutable, while the other two are mutable. Easy. For thread safety, both string and StringBuffer are safe, but StringBuilder is not. And finally, for performance, StringBuilder is the fastest kid on the block for making changes. And string is fast too, but only if you're not trying to modify it.
And here are those rules in plain English. Rule 1. If your text is fixed and will never change, use string. Rule 2. If you need to change the text and you're in a multi-threaded situation, you have to use StringBuffer. Rule 3. If you need to change the text in a normal single-threaded program, use StringBuilder to get the best performance. And honestly, that last one is the one you'll use most often when you need a mutable string.
And that wraps up our deep dive into Java string handling. Now you've got the knowledge to not just pass your exams, but to write smarter, faster, more efficient Java code. So the next time you kick off a new project, just ask yourself, which of these string classes is the right tool for this job? Thanks so much for joining us, and happy coding!